Now we will see question number 5. Question number 5 is prove using vectors the diagonals of a quadrilateral bisect each other if it is a parallelogram. We make the diagram. This is our quadrilateral A, B, C, D, and we take that position vector of point A is vector A, position vector of point B is vector B, position vector of point C is vector C, and position vector of point D is vector D. We have taken a quadrilateral. I have made it as a parallelogram, but right now I am saying it a quadrilateral. ABCD is a quadrilateral. Now I make the diagonals of it. This is my diagonal AC and this is the diagonal BD. The intersection point is, let us say, O. Now diagonals are bisecting at O, means midpoint of AC is O and midpoint of BD is also O, means position vector of midpoint of vector AC is equal to position vector of midpoint of vector BD. This is okay. Now position vector of midpoint of AC will be vector A plus vector C upon 2. So this will be vector A plus vector C upon 2, and position vector of midpoint of BD will be position vector B plus vector D upon 2. 2 and 2 are cancelled, and this gives us A plus C vector sum is equal to B plus D vector sum. Now if we have vector B minus A, then we can say this will be equal to vector C minus vector D. Means position vector of, this means that AB is parallel to DC. This implies AB is parallel to vector DC. Also, we can say from this equation that D minus A vector is equal to C minus vector B, which gives us that AD or DA is parallel to CB. So from the diagram, when we see, we find that AB is parallel to DC and DA is parallel to CB, means opposite sides of the quadrilateral are parallel, and therefore ABCD is a parallelogram. So therefore, since opposite sides of the quadrilateral are parallel, therefore ABCD is a parallelogram. Hence proved. Now we will see the next question.